Hey everyone. Hey everyone. How are you guys doing? Camera come correct. Sorry, mic is working. Okay. Hey, how are you guys doing? So I see many people are commenting that they were not able to submit code. So I believe the issue is resolved, or is it not resolved yet? I do see successful submissions as well and submission. So I guess the issue is resolved. Yeah, but let me know if again, like, if it is not submittable, then we'll just discuss on the questions. But yeah, uh, I think you have suffered today a lot. So sorry about what was happening. Can you guys hear me? Can you quickly comment if you guys can hear me? Not able to submit. You are still not able to submit. Okay. Not able to submit. Oh, that's weird. I tried till last minute. But how is the accuracy? Like, how are their submissions? I'm not sure. Let me just maybe write some dummy question code, right? So return 0, something like this. Let's try to submit this. Okay. Oh, it's stuck for me as well. Uh, yeah, I'm pretty sure the team. I have already informed them. I'm pretty sure the team is looking into this. Yeah, like, sorry for the inconveniences, but again, like, I understand that you guys are angry. You guys have given your time, but it's unfortunate that has happened. But again, like, it's okay, right? Like, it's just one contest which didn't get well, so maybe like, we'll make sure from the next time it doesn't happen again, right? But also, like, we'll just discuss on the solutions. Then if you're not able to submit, that's fine. Like, as long as you are able to write the code, or you are able to solve the problem, that's what is important, right? So yeah, like, we'll discuss the solutions, and then we'll see, like, if our solution was correct, or if we could have done that better, right? So that's more important, because this is for preparing you for interviews. So if you're able to write code, that's more than enough, right? I understand it is frustrating, because you're giving a contest, it should run, but yeah, like, not really, like, it's not something that I look into, so I cannot tell a lot about what went wrong, but definitely the team is pretty responsible. They will look into this. They are looking into this right now, so they will definitely find out what happened and make sure that it doesn't happen again, right? So yeah, it's a very unfortunate day, but okay, we got a message, all the best. Has it been extended? uh let's see. Contest home. I hope it's not extended, then I'm actually doing the live right now. uh but yeah. Okay. So let's discuss the problems. Yes, I think that's the I think that's what we should do right now, right? Instead of, I understand that you are furious and you have every right to be, but like, there's nothing that we can do right now, is it? So let's just like, look on the bright. Let's just try to, like, forget that, and just focus on the solutions as of now. I think that will be the, like, wiser thing to do, right? Yes, I completely understand, Vinay, and really sorry about your experience. Like, definitely it was not intended, right? Something went wrong again. Like, you understand, right? You guys are also programmers, so you also have bugs. So there has been some bug, definitely, and the team wasn't aware of that. That might happen. So yeah, like, I'm sorry that we had to run into this, but yeah, like, we have to be careful about this not happening again. This was my first test. I'm really sorry you had a very uh you had this experience in your first test. Right. I can only discuss the approach. I cannot discuss the correct solution. But yeah, like, we'll figure things out, right? We'll discuss together. Like, it's not that I have to be right, or you have to believe that I'm right. You can definitely, if you feel I'm wrong somewhere, or if you have a better solution, please let me know as well. so that we have to do this a bit collaboratively, right? So you have to help me out, I'll have to help you out. So we have to do this. And again, like that's good in one way, because again, like it will be more interactive, I guess, or we can make it more interactive if you want. But yeah, like that's how we have to do it right now. अरे यार gig bits क्या होता है? I also don't know what gig bits are, and if it's something related to goodies, I also want gig bits. मुझे भी बता देना किसी को अगर पता चले कि how to earn gig bits, right? So okay, let's actually start with the problems, right? So first problem is gig hits too many ones. So given a non-negative integer n, you are allowed to make the set bits unset. You have to find the maximum possible value of the query, so that after performing the given operation, no 3 consecutive bits of integers are set bit, right? So you are given, will you please do Java? Yes, I can do Java as well. Question 3 is BFS and Q. We'll see. ठीक है, we'll see what is question 3, what is question 2. And Java, yes, let's do it a bit differently today. Let's try to write the code in Java. Again, I haven't done a lot of comparative programming or DSA questions in Java, but yeah, like I have a bit of experience in Java, so I hope that I can able to write some code. I will be able to write some code, but yeah, like definitely help me out if I'm not able to. Okay, so the question is, we are given n equals to 2, and we have to tell what is the what is the maximum possible value that we can get after the query, and what is the operation that we have to do, or what is the thing that we have to do, that we have to ensure that no 3 consecutive bits are set bits, right? And what we can do is we can make a set bit unset. So after the query is over, we have to make sure that no 3 consecutive bits are set, and we have to return what is the maximum possible value after doing the operation. Like after ensuring that no 3 consecutive bits are set, what is the maximum possible value that we can get, right? So okay, so let's understand what exactly is happening here. So for n equals to 2, we have the output 2, because again, binary representation of 2 is 1 0, that has only 1 1, no 3 consecutive ones are there, so it will remain 2, right? For 7's binary representation is 1 1 1, so you have to remove 3 consecutive ones, right? So we can, what are the possible combinations we can have? So we can have we have 1 1 1 as 7. We can either remove this one, so 1 1 0, we can remove the middle one, or we can remove the leftmost one, right? Now which one to remove? It's always better to remove the rightmost one, because again, like that has a lower significant bit. So that is the entire logic of the problem. If you have 3 consecutive ones, you should always remove this one to 0. You should always make this one 0, right? So that should be the entire that should be the, because again, like just think about it, why this is valid is because a 1 here, 1 0 and 0, let's say 1 0 0, any one and after that a zeros is much better than 0 all ones after this, right? Because this will be equals to some 2 to the power k, and this will be equals to 2 to the power k minus 1. So this 1 at a higher significant bit is much better than all ones in lower significant positions. So that's why we will always make the third set bit unset. We'll start from the right hand side. So the solution will be, we'll start from the right hand side. So let's say we have something like this: 1 0 0 1 1 1 1 0, or 1 1 1 0 1 1 0 1. In this case, what we'll do, we'll start from the right hand side, left hand side. We'll see 1, then there is 0, so no 3 consecutive ones are there. We'll go ahead here. We have seen 1, we have seen 1, we have seen 1. Now this is the third one we are seeing, so we'll make this 0. Now here we have seen 1, again we have seen 1, let's say this is also 1. So we have seen 1 again. So again you have seen 1, so we'll make this 0. Again 1 1, then we have a 0, so we don't have to make any changes, and 1. So this is the final result that we'll have. Okay, this is the result that we should have. So that will be the logic. We'll start from the leftmost position. and we'll go towards the right hand side. That is we'll start from our most significant bit, we'll go downwards to the least significant bit, and we'll see if the corresponding bit is set. If 3 consecutive bits are set, we'll unset this bit, otherwise we'll keep it, right? So keep it as it is. So that should be the logic. Let's try to write the code for this in Java. Okay. The constraint is n is 10 to the power 9, so it should be done. It should be done within order of it should be done within 32 bits, right? 31 bits. So for for int I equals to 1. Also for int I equals to 31, I greater than equal to 0, I minus minus, right? For int this thing. Okay, what we'll do here is we will also need the count of ones. So count ones initially is 0, and count once is 0. So if query, if the current bit is set, right? So query ampersand 2 to the power I, query ampersand 2 to the power I, this will check if the ith bit is set or not. If this is set, count once plus plus. So if count once is equals to 3, at any point of time it is equals to 3, in that case what we'll do is we'll reset the bit. So what we'll do is query will unset the bit. So XOR equals to, and we can do this inside as well, although outside it will never be true, but inside also we can do. And if we see if it is equals to 3, then query XOR equals to will unset the bit, right? We'll unset the bit. How do we unset? We'll do a XOR operation. XOR equals to 1 to the power I. We'll unset the ith bit and we'll make count once equals to 0. And we'll do like this as long as we can, and return count once. Return query. And that should be our solution. So let's try to run this on, I'm not sure if we can run this as well, but yeah, let's hope that we can run. Okay, yeah, it should be greater than 0, right? It should be greater than 0. I used bitset query, and I have missed one more. Yeah, this should be it. Let's see if this runs and it is giving the correct result or not. For 2 we are getting 2. Let's test it against some custom input. So for 7, first of all let's test for 7. So let's run 7. My output. Also, okay, yes, that's a good thing. When it encounters 0, right? When it encounters 0, when it is not set bit. When it is not a set bit, then we should also reset count once, right? Because otherwise it will be carried forward. So count once equals to 0. Yeah, this is something that I missed. So yep, right, you're right. What is okay? What is 1 right shift I, right? 1 left shift I, right? So this is basically 2 to the power I. So again, what does left shift mean? It is like if you have a bit, right? If you are left shifting by one place, if you are doing left shift by one place, it will be all the bits will be shifted to the left. That is, a 0 will come here and a 0 will be gone from here. So it will become like this. See, so basically a left shift does 2 into, right? A left shift does 2 into the previous number. So if you left shift 1 I times, left shift 1 time, it will become 2. So it will become 2 in 1 time. It will become 4 in 2 times, because it will become 100. In 3 times it will become 100. So it will become 8. After that it will become 16. So eventually it will become 2 to the power I. If you left shift I by okay, so if you left shift I by if you left shift a number 1, if you left shift 1 by I times, it will become 2 to the power I. So if you left shift any k, right, any k by I times, it will become 2 to the power I into k. 2 to the power I into k. It becomes 2 to the power I into k, right? So that is basically what left shift does, right? So here we are checking query and 2 to the power I. So what is 2 to the power I? Let's say we are checking for the second bit. Second bit, that is 2 to the power 2 is 100. Second bit means 0th bit, first bit, second bit. So 2 to the power I, 2 to the power 2, I is 2 here, 2 to the power 2 is 4. So the binary representation is 100. Let's say the number has the second bit set, right? So let's say it is something like 10100. The second bit is set here. So when you AND with this, what will happen? This will AND with a 1, 1 and 1. So we'll get a 100 output. So that is greater than 0. That means the corresponding bit is set. If the corresponding bit is not set, if it was 0, then the entire AND operation would have resulted in a 0. So this is how you can quickly check if the ith bit is set or not. This is for checking if the ith bit of query is set or not. XOR equals to, XOR means, what is the property of XOR again? XOR. This is XOR basically. 1 XOR 1 equals to 0. 0 XOR 0 is equals to 0. So basically if you are XORing with the same element, it becomes 0. That is A XOR A equals to 0. That is the property, right? So what we are doing here, we are seeing the ith bit is set and 3 ones we have already seen. So we are unsetting the ith bit. So already it is set. We are also XORing it with 2 to the power I. That is, we are setting the ith bit. So that becomes unset. So we are unsetting the bit here. Okay. This is the trivial approach. Trivial approach, इसका trivial approach क्या होगा? You can it is hard to write a trivial approach for this. What was the question again? We have to tell what is the minimum. Okay, you can go like you can do query minus minus and check if no 3 bits are same, and then you can return the answer, right? So that would be a trivial approach. Again, like it is expected that you already can write the trivial approach. Like trivial approach will be as simple as while query minus minus, like this, right? While query minus minus, if let's say there's a no 3-bit set. No 3-bit set is a method. You call this on query. In that case, you will return query and something like that. So that will be a trivial approach. Right. Loop should start from 30. So there are 30. So 2 to the power 31 minus 1 तक range करता है, right? हाँ, so I think it should start from. It is okay to start from 30. I think, yeah, because 2 to the power 31 minus 1 तक जाते हैं. So it will be from 30 also we can start, right? 10 to the power 9. So 2 to the power 30 should be greater than 10 to the power 9. That should be, yeah. So yeah, you can start from 30 as well. That will work. But anyways, that is the logic. Like what we are doing, we are traveling in a reverse loop. We are seeing if the ith bit is set. We are then increasing the count of the number of ones. If the count of the number of ones we see is 3, we reset. We'll reset that bit, right? We'll reset that bit. We'll reset that bit, and yeah, we'll reset that bit, and we'll set count ones to 0. Otherwise, we'll set count ones to 0, and finally we'll have the answer. Right, that can also be a trivial approach. You can actually, instead of doing bitwise operations, if you're not comfortable with bitwise operations, you can actually store the bits in an array, right? You can convert it into an array, and then you can check if the 3 bits are consecutively set. Then you can make them 0 and something like that, and then reconstruct the number back. So that will be the first problem. Let's go to the second one. Why can't we start the loop from 0th bit? Because the question demands you have to tell the maximum possible value, right? If you start from the 0th bit, will you be able to tell the maximum possible value? You would remove a higher significant bit, right? In that case, you will remove, because you will be counting 3s. So let's say it is 1 0 1 1 1. So first of all, you start from the 0th bit. It is 1 1. Third bit is 1. Now you remove the third bit. So in that case, it will cause a problem, right? So you should always start from more significant bit, because it is always better to keep a more significant bit than a least significant one. Okay, let's go with remove the balls. Remove the balls. So imagine an imaginary array of length n containing balls given two arrays, color and radius of length n, where color of I represents the color of the ith ball and radius of I represents the radius of the ith ball. If two consecutive balls have the same color and same size, both are removed from the array. Geek wants to know the length of the final imaginary array. So we are given two arrays, right? We are given two arrays, one representing the color of each ball, ith ball, radius, and the second representing the radius of each ball. So color of I is the color of the ith ball, radius of I is the radius of the ith ball. It tells that if two consecutive balls have same color and same radius, they will be removed. What is the length of the final array that you get? For example, let's actually consider the example, right? 1 2 3 5 3 5 1 2. This is a good example. So see, 1 2 3 5 3 5 1 2. 1 2 3 5 3 5 1 2. Now see, these two are similar, these two are consecutive, these two are similar, so they will be removed. They will be removed. But now it is the interesting point. As they are removed, now if you see 1 2 and 1 2 come next to each other. So now they are also similar, so they have to be removed as well. It is not like 1 2 and 1 2 will not be removed, because they, after removal of the 3 5 3 5, they are coming next to each other. So they have to also get removed. You have to remove them as well. So the answer for this should be 0, right? Let's check if it was 0. Yes, the output should be 0, because they become next to each other after this. So this is the question, right? So basically it doesn't exactly tell that it has to sit next to each other. It is like after performing the operations as well, if two elements come next to each other and they are similar, they also have to be removed, right? So that's the tricky part. Yes, that's the correct solution, right? So whenever again, this actually brings us to a nice observation, that whenever there is a problem, right, whenever there is a problem, that tells us in which you might have to revert back. You might have to revert back to the previous elements. For example, in this case as well, 1 2 3 5 3 5 1 2. In this case, you already have seen 1 2. After that, you are going to 3 5. Then you are seeing 3 5 and you are seeing they are similar, so you are removing them. They are getting removed. Now you are again revisiting 1 2. So if there is a problem where you have to revisit an element, where you have to revisit an already visited element, right? In that case, you can use a stack always. Because why a stack? Because whenever you remove from the top of the stack, this will come on the top. This will come at the top. So for example, let's understand how we can leverage a stack here. We'll maintain a stack. First of all, we have 1 2. So we'll insert 1 2 into the stack. Then we will have 3 5. So is 3 5 equals to the top of the stack? No, right? So we will insert 3 5 into the stack. Next we have another 3 5. So we'll check now. Is 3 5 equals to the top of the stack? Yes, it is. So we can remove the top of the stack as well. And we will not even insert this 3 5 because this will also get deleted. Next we have 1 2. Now with 1 2 we can check if it is equals to the top of the stack. It is equals to top of the stack, so we will remove this as well. So this will get removed, and this 1 2 will not be inserted as well, right? So that is the, and this becomes empty. Now we are done with all the elements. So it is empty, right? That is the answer. Right. Again, the question is, you are given n balls. Each ball has some color. Each ball has some radius. If two consecutive balls have same color and radius, ri plus 1, then you will remove them. Both of them will be removed. Now the balls beside them, this ball and this ball, they will come next to each other because both of these balls have been removed. So they will come next to each other and you have to compare again if they are equal or not. You have to return what is the number of elements that are remaining after doing these operations, right? So and you can actually convert this to a bracket matching problem as well. So the first occurrence you can treat it as opening bracket, the second occurrence of an element you can treat it as a closing bracket, and you can check if if it is matching. Although it's not exactly a bracket matching problem, but again we are using a similar algorithm here. So yeah, again, so here we are inserting 1 2 first into the stack, then we have 3 5 coming in. We see that 3 5 is not equals to the top of the stack, so we'll insert 3 5. Then we have the next 3 5 coming in, so we see 3 5 is equals to the top of the stack 3 5, so we'll remove this 3 5. Now we have 1 2 coming in, so we see 1 2 is similar to 1 2 on the top of the stack, so we'll remove this as well. So the answer will be 0. Can we do using recursion? No, this is a stack problem. Like recursion, it calculates the complexity. So if the complexity becomes more, in that case, again, like recursion is a stack eventually, right? Recursion is a stack eventually. So if you see the complexity is order of n, then it's fine. If you are doing it some other way, then it's not fine, right? So recursion is anyways a stack eventually. So I think recursion should work as well if you do it properly. Okay, so okay, let's write the code for this. So what we'll do here, we'll take a stack, and the stack will be of pairs, right? In fact, we can write in Java as well, as we are writing in Java, but I'm not sure how to create a stack in Java. I guess it's stack only, but let's see. Stack, and let's create a class called pair, right? And it will have int xy and int xy and public. Let's create a copy constructor, int x, int y. This dot y equals to y. So stack pair, stack equals to new stack. New stack should do. Let's see how to create a stack in Java. Or is this code running even? So let's run return 0. Return 0. Return 0. Okay, new stack. Sorry. Okay, completed, but yeah, that's fine. So we have the stack, new stack. So what we'll do is we'll go through all the elements, right? We'll go through all the elements. So for int I equals to 0, I equals to 0, I less than n, I plus plus, right? So I equals to 0, I less than n, I plus plus. So paired p equals to new pair, color of I, the pair of color and so we are creating a pair of color and the radius, right? So color of I and radius of I. So if not stack dot is empty, I'm assuming that there is a method called is empty, and the top of the stack, so let's call it stack dot, what is the top of the stack? I could have used an ID, so stack Java. Let's quickly look into the implementation. What are the methods? So stack.pop is there, stack.pick is there. Okay, stack.pick is there. Awesome. And yeah, that should be, and stack.push should be there. Okay, so yes, stack.pick. Okay, stack.pick and then stack.pick. So it gives us the object. We want to check if the x is equals to dot x is equals to color is equals to p dot x, and then stack dot pick, the y is equals to p dot y. So if x is equals to x and y equals to y, in that case what we want to do is we want to remove that. So also we want to mark this as matched. So boolean matched is equals to false, and here we'll set the matched to be true, and stack.pop, right, stack.pop. And now if not matched, in that case stack.push p, stack.push p, and finally return stack.size. That should be the final answer. So let's see. Sort on the basis of color and radius. Yes, we can do that, but again, like, this is a order of n approach, right? Whenever you sort, it becomes order of n log n, so this is much more optimal. So the output is 1, which is this 1? Yes, it should be 1. Again, like, let's test this out as well quickly. So n is 4, and after that 1 3 3 1 2 5 2 5 5 5 2. Right. So let's see the expected. Okay, sorry, my bad. My output, it should be 0. Right. You cannot sort because of consecutive condition as well. So you have to maintain the indices, and it becomes complicated unnecessarily. Right. Whenever you sort, they come together, but again, like, you have to maintain the fact that all the elements in between are also equal, so that becomes unnecessarily complicated. So again, like, for these problems, stack is the approach that you should follow. Yes, right. Thanks, Rohit. So yeah, that should be the second question, right? That should be the second question. I'm not sure how people are submitting as well. Can we submit this one? Let's see. I don't think we can submit. Okay. Anyways, let's solve this one. What is the output of 1331? Okay, tell me the input. 1331 2652. Okay, 2652, it should be 4, because like these two are not getting removed, so it should be 4. It should be 4 itself. All the elements should be there. So my output should be 4, and expected should also be 4. Let's test it out. So I'm getting 4, expected also. Let's test it out. It should be 4. Okay, it is also 4, right? So it is 4. Anyways, can we use hash map for the second question? How would you use a hash map? Again, like, you have to make sure that the consecutive elements are similar, right? So what will be the purpose of the hash map? Like, it is not like if two elements, like for this, if 1 2 and 1, what Piyush gave the example, right? 3 6, if it becomes 3 6, it's not like you will remove this 1 2 with this 1 2, right? They should be there because this 3 5 3 6 and 3 5 didn't match. So you have to make sure the consecutive factor is also taken into care, and after that you can use anything that you want. Maybe some people are lucky that they're getting their solutions are getting submitted. Let me see what exactly is happening, right? So let's see. तो कर लेते हैं नेटवर्क बस कंसोल हटा देते हैं. Let's submit and see what's happening. Compile. रिजल्ट भी आ रहा है. रिक्वेस्ट क्यूड. अच्छा, गॉट इट. तो it is getting queued, but maybe queue may break ho gaya. Like I think it's the queue is broken wherever it's queued, so somehow it is like clogged up, or it is some server shut down, so that might be the case. Okay, anyways, okay, let's try this one right now. This is a good question. So okay, geek loves two factor, right? Geek loves two factors. You are given an integer n where query is a non-negative integer. Query is a non-negative integer. N is basically, I'm not sure what is n actually. So you are given an integer query. So this is actually wrong, statement is wrong. You are given an integer query where it is a non-negative integer. You can make any integer x as x plus 2 or x minus 2 in one move, right? Please note that after the operation, the resultant number should not be negative. Any number can be expressed as product of exactly two distinct prime numbers is considered to be good number. So if a number is expressed as a product of two distinct prime numbers, it is a good number. Please note that multiple occurrences of any prime number is not allowed to be a good number. Geek wants to know the minimum number of moves required so that integer query becomes a good number. When will be the next practice section? It will be next Sunday again. Geek wants to know what is the minimum number of moves required so that the integer query becomes a good number. So basically what is the question? You are given a number, let's call it query. What you can do is, you can do query minus 2, query plus 2 any number of times you want, provided it doesn't turn negative. You have to stop, what you have to do is, you have to convert query into a number such that it is a product of two distinct prime numbers. You have to tell what is the minimum number of moves that you need to do so that you can achieve this. Right? So n equals to 2. So for example, n equals to 2. What is the minimum number of moves? So after two moves, you can convert 2 to 6, right? X plus 2, it will become 6. And 6 is 2 into 3, which is a product of two distinct prime numbers. So the answer will be 2 moves, right? Similarly, 8 can be converted into 6 in one move, minus 2, and again it will be 3 into 2. So 1 move is needed. So what is the minimum number of moves needed? I couldn't understand the question. Okay, so you are given, let me try to explain again. So you are given an integer n. What you can do is, you can do n minus 2 or n plus 2 as many times as you want. What you have to do is convert n into some x which is equals to some p into q, where both p and q are primes. That is, it is, and p not equals to q. It is the product of two distinct prime numbers. What is the minimum number of moves of this type that is needed to convert n to x? For example, 8, you can convert it to 8 minus 2, that is 6. And 6 is equals to 2 into 3, which is two distinct prime numbers. So it is valid. So in one move, you can convert 8 to 6. Right? Okay. So how can we solve this? Let's understand this. First thing we can do is, let's say we are given a list of good numbers. Okay, first thing first. What are the moves? The moves are n plus 2 and n minus 2. That means a even number will always stay even, a odd number will always stay odd. That is for sure. Now we are given a list of good numbers. Let's say we are given a list of even, good and odd good numbers. What are good numbers again? Good numbers are the numbers which can be expressed as a product of two distinct prime numbers. those are good numbers, right? So you have a list of even and a list of odd good numbers, different lists, right? Two lists. If you are given this thing, can you tell what is the minimum number of moves that is needed for n to reach to the nearest one? Can you tell? If you are given a list of even and odd good numbers, can you tell what is the number of moves needed for n to reach the nearest good number? Can anyone tell? You are given the list of good numbers. How can you, what, or at least can you determine what should n be converted into? What should n be converted into? Yes, very good. Shivam, very good. You have to take the lower bound. That is, you have to find in the list, right? You have to convert n using minimum moves, right? So in the list, what should you convert into? You should convert into the nearest ones, nearest good numbers for n. So you should find the lower bound. Let's say this is the lower bound. So this one you should compare with this one and the previous one, because this will be lesser, this will be greater than equal to. So you should take these two elements and compare n, and this is only where n should be moved to. N cannot be moved to these things because these will need more moves. You have to convert in the minimum number of moves. So this is where you should search. Yes. So once you get this, let's call this P. Let's call this Q. Once you get this P and Q, what you can do is you can search. We can see which one is minimum. P minus n by 2 or n minus q by 2, whichever is minimum, you will need that. That is the number of moves. अरे भाई कुछ रिकर्शन वगैरह नहीं लगेगा, इधर तो अलग ही नशे चल रहा है. रिकर्शन सुन लो क्या बोल रहा हूँ, फिर डिस्कस कर लो. So you are given a list, right? If it is sorted list, you can binary search and find what are the nearby elements, nearby good elements, and you will definitely convert to one of them. So you can find the number of moves as well using this p minus n by 2, that is the difference by 2. You can easily find. If we find the factors of n, that then we can do the problem. Not really factors. Why dividing by 2? Because x plus 2 move हो रहा है, x minus 2 move हो रहा है. So you are jumping by 2 steps. So that's why divided by 2. ठीक है? Okay. So you are okay. You have the list. You know now that you can binary search and get the answer, provided you have the list. Now the question becomes, how do we construct this list? How do we construct this list? That is the question. Right? How do we construct this list? Okay. So we construct this list using Sieve. We will construct this list using Sieve, especially one variant of the Sieve that is called SPF, smallest prime factor. So what is SPF? SPF of I is equals to the smallest prime factor of I. SPF of I is the smallest prime factor of I. Okay, smallest prime factor of I. Now how can we use the SPF? Let's forget about how do we calculate this SPF array. For now, let's forget about how do we calculate this SPF array. Rather, let's think if SPF of I, for each I, SPF of I stores the smallest prime factor of I. What is the smallest prime factor? For example, SPF of 6. What is the prime factorization of 6? 2 into 3. What is the smallest prime factor? 2. So 2 will be the SPF of 6. Similarly, SPF of let's say 15. So what is 15? 15 is 3 into 5. So SPF will be 3. Right? The smallest prime factor. So provided you have the SPF, how can you determine if a number is a good number or not? So we know a good number is what? A good number is of the form of P into Q. Two distinct prime numbers, right? A good number is of the form P into Q, two distinct prime numbers. So that means if one of the prime numbers is SPF of I, if one of the prime numbers is SPF of I into Q equals to the number A of I, let's say. SPF of I into Q equals to, not A of I, sorry, I. SPF of I into Q equals to I. Right? So what should be Q? Q is also a prime number. So we can check if Q is equals to, if Q, that is I by SPF of I, if I by SPF of I, if the SPF of this, if this should be a prime number, this should be prime, I by SPF of I should be prime. What is the property of a prime number? Property of a prime number is SPF of a prime number P R is equals to PR. It is the smallest prime factor of itself. So that is the property of a prime number. So if Q is a prime number, then that means SPF of I by SPF of I is equals to I by SPF of I. Right? So again, or you can just determine Q is equals to that, and you can just check if SPF of Q is equals to Q. If that is the case, in that case I is a good number, otherwise I is not a good number. So using the SPF array, we can see that we can compute the good numbers, we can find the good numbers. But one more thing to note here, how to compute this SPF array, right? How to compute this SPF array? So we'll use the sieve method for this. So initially we will have SPF of I equals to I for everything. So let's try to do the sieve up to 10, right? So 0, 1 is 2, 3, 4, 5, 6, 7, 8, 9, 10. Okay, we'll start from here, from 2. SPF of I, if SPF of I equals to I, it is true, we'll go through all the multiples. This is a prime number, so we'll go through all the multiples. That is what we do in sieve. We'll go into the multiple, that is 4. 4 will convert, we'll see that it is, the SPF will be 2. We'll update this. So 0, 1, 2, 3, 4, 5, 6, 7, 8, 9, 10. Similarly, we'll go to 6. We'll update the SPF to 2. We'll go to 8. We'll update the SPF to. We'll update the SPF to 2. We'll go to 10. We'll update the SPF to 2. So we are going through all the multiples of 2. Right? Same as sieve. We'll mark them as 2. Now we'll go to the next element, 3. Is 3 a prime number? SPF of 3 equals to 3, so 3 is a prime number. So we'll go through the multiples again. We'll go directly from I into I, 9. So 9 will make this. SPF will be 3. And then it will go to 12, so it's not there. Then we'll go to 4. Is 4 a prime number? SPF of 4 is not equals to 4, so it is not a prime number. Is 5 a prime number? Yes, 5 is prime number. So 25 is not there, so we'll not update anything. Then see, we have actually identified all the prime numbers up to 10, and the prime numbers have their SPF to be itself. Right? Ten to the power 9 is more than 32 bit. I don't think so. Just check if it is. How is it more than 32 bit? 10 to the power 9 plus 7 we take modulo as integer. 10 to the power 9 is like something. It's in the range of 10 to the power 9, but more than 10 to the power 9. 10 to the power 9 is within 32 bit. It's within integer. Okay, so this is SPF, right? This is SPF. So this is how we'll compute SPF, and then we can use the SPF to compute the answer. We'll create the good numbers list, and in that we'll search. We'll do binary search. Okay. So that should be the solution. Let's try to write the code for this. Okay. We'll use I'll use C++ for this. I'm not very comfortable with Java here, so let's use C++ for this. Test cases are not passing because some internal server error is happening. We have already discussed this at the beginning. There is some error on the server side. The team is looking into it. Yeah, like it was a bad experience, but again, like we are just trying to discuss the solutions and understand if we are right, if we are wrong. So and learn something out of here, right? So that's the logic. Okay. So anyways, so what we'll do is as well. So we will not compute everything every time, right? So we'll keep things pre-computed, right? We will keep the elements pre-computed, right? The answer or rather we'll keep a few things pre-computed, right? So that we do not have to compute again and again. So okay, so let's see what we can do here. Constant n equals to, let's find all the numbers up to 1e5 2e5, let's say 2e5 up to 2e5. Let's find all the elements, right? So vector int even good numbers, or let's maintain a set will also work. Set int even good numbers, set int odd good numbers, right? So yeah, also we'll need the SPF array. So vector int SPF. So vector int vector int void prime void sieve, right? So SPF equals to vector int, or rather let's do it like this, that for int I equals to 0, I less than n, I plus plus, SPF dot pushback, SPF of pushback I, right? So SPF dot pushback I, right, initially. So for int I equals to 2, I into I, how do we write sieve? I into I less than n, I plus plus. For int j equals to I into I, j less than n, j plus equals to I. This is how the sieve loop looks like. So if SPF of I is equals to I, sorry, we'll only run the second loop whenever this is true. So if that's true, we'll run this j loop. If it is a prime number, run the j loop. That will go through all the multiples, and SPF of j is equals to minimum of SPF of j already what is there, or I, the minimum of that, right? So we find the SPF like this. Okay, we find the SPF like this. Now let's write the constructor here, solution, and also let's write the method void construct good numbers. For int I equals to I equals to, I believe, what is the first good number? The first good number will be 6. So I equals to 6, I less than n, I plus plus. So int q equals to I by SPF of I. Also, let's reset 1 and 0. So let's make sure that SPF of 0 and 1 not equals to themselves. So SPF of 0 equals to -1, SPF of 1 equals to -1, right? I by SPF of I, and also if it is not prime as well. So if SPF of I not equals to I, if it is not a prime number, only then we'll do this. So int q equals to I by SPF of I. Okay, if q equals to SPF of q, then it is a good number. So if q modulo 2 is equal to 0, then in case of even good numbers, we'll push it. So even good numbers dot pushback. Sorry, if not q, it is I. If I modulo 2 dot pushback I, else odd good numbers, or it is set, right? So we'll use insert. Instead of pushback, we'll use insert as it is a set. So odd good numbers dot insert I. So we have computed the good numbers like this, right? So in the constructor we'll do this. So solution, and we'll construct this. So sieve, first of all we'll call sieve, then we'll call construct good numbers, and that should do, right? So for the query, what we need to do is we need to find the lower bound. So auto it equals to value at lower bound, or rather auto it equals to lower bound, sorry, even so first of all, even or odd. So if query modulo 2 is equals to 0, then it is even. So in that case, auto it equals to even good numbers dot lower bound query, right? And yeah, let's maintain the answer as well. Int answer equals to, if it not equals to, so int answer equals to we want the minimum number of moves, right? So let's initialize with int max. So if it not equals to if it not equals to end, right? So if it not equals to even good numbers dot end, which should not be the case, but anyways, in that case, what we'll do, answer equals to what should be the answer? It should be equals to value at it minus query, value at it minus query, and divided by 2, right? Divided by 2, because each move is plus 2. And else, yeah, sorry, not else. Now what we'll do is, if it not equals to even good numbers of begin, so we can go to the previous element. So it minus minus will go to the previous element, and answer equals to same thing, query minus, now it is less than query, right? So now query minus value at it by 2, and same thing will do for odd as well. So let's just copy paste this thing and return answer here. And same thing we can do for the odd case. So else this should be odd good numbers, and here it should be odd, and here it should be odd. So that should be the difference, and return answer. Yeah. And also if you want, you can cache it for some queries as well, so that it is not computed again. Arey bhai, you guys are worried about streaks and these. I have no idea. Ask the admin panel about if it is reset or something. For input 2, output is 2. For input 2, output is 2. Okay. For input, let's see 8. It should be 1. Let's see if it is 1. It is 1. So that is how we can compute the answer. So we have learned about SPF here. It was a good question overall. We have learned about SPF here and how we can leverage SPF into these problems as well. And also one more thing that we have learned is if you want to convert something to if you want to convert something to some other number, right? If you want to like have some moves and then convert to a number, in that case it might be, and you want the minimum number of moves, so it might be a good idea to actually construct those numbers and then binary search on the numbers to find like what are the nearby numbers and then find the like minimum number of moves, right? Is this a DP problem? Please rewatch the video. I'm not going to repeat this. Any questions on the approach? Any questions that you have on the approach? If you have joined late, please rewatch the video. And it is not a DP approach. What you can do is you can do some memorization here. Like if a query is already computed, in that case you can just return the answer, whatever is there. Otherwise you can process it. Those things you can do. But it is not a DP problem. It's a simple ad hoc problem. Okay. If you have any doubts, let me know. Otherwise, we can call it a day. Like we have done all the problems. If you have any doubts, let me know. Otherwise, let's call it a day. I don't think you guys have any doubts because no questions. Okay. Cool. Answer variable change. Yes. So basically this part. So what does lower bound return? Lower bound will give you the element that is greater than equal to the element you are searching for, right? So it will give you the upper it will give you the element that is in the even good numbers array or the list. What is the element that is greater than equal to first element that is greater than equal to query, that will be given. But also you can go downwards, right? You can do -2 as well. So you have to go to the previous element. So in that case what we are doing is, if it is not equals to the begin, it is not the first element, so we'll go it minus because then the previous element will be the nearest element that is less than the closest element that is less than the given number, and then we are updating the answer. All right. Is this clear, Uttam? Let me know. In Java, no, there is no lower bound, but there are collections, like with collection.sort, there are some parameters that you can pass. I think there was something, a bisection or something like that, that basically calculates the lower bound. So you can do lower bound as well, but with a different name. If it is not supported, you can always write the code for lower bound as well. That it is not very difficult. No, you can do lower bound in Java as well. Just search for it. Lower bound Java. It is not exactly called Java lower bound, but you can do lower bound searches. So GeeksforGeeks has all the questions. you can just search for this. So okay, it has implemented on itself iteratively. I hope it has something called okay, it didn't give that, but yeah, like Java equivalent, I think Stack Overflow should have that. Collections.binary search. Okay, so collections.binary search is there, so you can do that as well. For 2, the output should be 2. Think about why it should be 2. For Java, we have discussed, right? It is collections.binary search. Cool. Output for 10. Output for 10. 5 into 2. Yeah, it should be 0. My output, it should be 0. Okay, for me also it is coming 2 somehow. Oh, we are not checking if it is a number. 1 second. Even good numbers. 10. 5 into 2. 10 is not a good number. How is it not? SPF of I. See out. Let's do one thing. 5 into 2, right? So SPF of 2 is equals to 2 for sure. That's happening here. SPF of 10 will be 2. Then it will go to 5. 5 is SPF of itself. So if SPF of I is not equals to I, that's true. Q is I by SPF of I. If Q, if I modulo 2 even, then odd. Let's if I is less than equal to 10. If I is less than equal to 10, see out I. Let's see if we get 10 as the in the list. Okay, we get 10, right? We are getting 10. That's good. 1 second. Where did we write the C out? Okay, here. So we are getting 10 in the list for that's good thing. So here when we are searching for this query mod 2 even dot lower bound query, if it not equals to even good numbers dot end. Yes, it is not in that case. Let's do C out. Evaluate IT and then let's run for this thing. My output. If we have duplicate elements, then collections.binary search doesn't work. Don't store duplicate elements. You can always use a map to not store the duplicate elements, right? Or you can use a set and then convert it to a list. You don't have to store duplicate elements. 10 to okay, 10. We get 10 here. IT is not equals to even good numbers dot end. That is true. Answer equals to evaluate IT minus answer equals to, okay, we are not doing here min, so it should be minimum of answer comma query by 2, right? So it should be the minimum of them. My bad. So it should be the minimum of them. Here also answer equals to minimum of whatever answer we have found or this thing, right? So now it will give you 0. For 15 we'll get 0 now. 15 also we should get 0 now. Now it should work. Basically this main statement was missing, so this was getting replaced here, right? Now we will get 0. Cool. So yep, I think that answers all your questions and this code should work now. So yep, thank you guys for joining in, and I'll be seeing you next Sunday. Hopefully the contest doesn't mess up like this, but yeah, like I'll see you next Sunday.